Mary and Crystal are going to be monitoring the chat for questions. So if I'm talking too fast, or if you have any specific questions, please put them in the chat, and someone will see them and make sure that I stop and answer them. As we go, we're going to have a bunch of practice examples. So if you're having a ton of trouble with your specific code, or if what you're doing is breaking, and the chat is not helping to get to the problem, you can also make an issue on the GitHub site for this project, and we can see if we can dive into it there. But before we get into any of that, let's introduce myself. So thank you for the great introduction. I am Erin. I'm a data scientist at Uncommon Schools. Uncommon Schools is a charter management organization in New York City. So what that means is that we are a company that runs a bunch of charter schools. So we have 53 K-12 schools in, let's see if I can get all the states correct, New York, Massachusetts, and New Jersey, specifically Brooklyn, Rochester, Troy, Boston, and Newark and Camden. So lots of regions, lots of states, lots of schools equal lots of data. And being in education means lots of messy data because it was all entered by hand. So I deal with incredibly messy data all of the time. And that is why it is my realm to talk about and hopefully guide you there. Please keep yourself on mute if you are not asking me a question. Thank you. Okay, so requirements. So as we walk through the workshop, we're gonna be in our studio. I've set up a couple example notebooks so that you have some pre-code to look at so you don't have to copy exactly what's on the slide. So please make sure that you've downloaded the notebooks and the data from the GitHub link, which Mary has put in the chat. Thank you, Mary. And please install Tidyverse and Janitor so that you can dive right in. All right. All right, jumping into things. So a quote that I love very much from Hadley Wickham is that tidy data sets are all alike, but every messy data set is messy in its own way. And the reason that I like this is that it gives a kind of good definition of what tidy means. And it means that it's data that you can work with in the way that you want to work with it, is sort of how I like to think about it. But messy data, it doesn't work the way that you want to work with it, or has a bunch of erroneous columns, or in what we will see ahead, has many, many duplicates that you then have to deal with. All right, so in order to solve our messy data problem, we are going to learn about this wonderful package called Janitor. So Janitor is a package written by Sam, who also works in education. So he wrote this package largely to solve education problems because Sam is awesome. And because I've given a talk on Janitor / this workshop on Janitor so many times, I've adapted this silly cat GIF to be Janitor's official GIF. But Sam hasn't done that yet. So it is my official Janitor GIF because it's so wonderful and I love cats. So this is a quote from Sam on the Janitor README. The important part of this that I like is that the Janitor package is written as a helper package. So pretty much everything, all of the important functions in Janitor, you should be able to do on your own with basic dplyr functions. But you don't always have the time to write out all the dplyr functions, or you may not know how to do them in the right order, in the right way, as fast as just having the function provided for you. So what Janitor does is write all these helper functions for you so that you can clean up your data with 1 or 2 functions rather than having to combine all of the dplyr functions. But under the hood, it's just dplyr at the end of the day. So it's nothing super complicated. All right, so if you haven't already, make sure that you've downloaded or installed the Janitor package, and then also opened the Janitor notebook. So I'm going to hop into my Janitor notebook so you see what it looks like. So hopefully you can see. So it looks something like this. It's gonna have the title Janitor Notebook at the top of it. And we're gonna be using this fake students data to start with. So please, if you haven't already, make sure that you open that. And if you have any questions on how to find it, you can shove them in the chat. The notebook is from the GitHub. Correct, the notebook is from the GitHub. It is in the folder labeled notebooks, because I'm very creative. I'll give everyone a second to do that. All right, so I'm seeing some nodding, so I'm gonna go ahead and move on. But please stop me if you need a second. So Janitor has a ton of awesome functions. We are going to focus on 2 of them. So the function clean names and the function get dupes. So we're gonna start with the clean names function because it is the easiest and the best. So can someone type in the chat what the benefit of cleaning names might be? Don't make me pick on you. I'm seeing some great answers. So we've got, does it standardize the names or titles so that they're in the same format as one another, easier to understand, standardize, easy to know what we're working with. These are all great answers. So yes, easy to visualize, short and variable names for long questions. Definitely love that. Looks like it translates special characters to normal. Yes, JH. So that is, in my opinion, the most important part of clean names. So you may have seen before, if you try and use dplyr commands with a variable that has a space in it, that you need to put the single quotes that aren't actual quotes around your variable names so that R knows that it's a full name altogether with this weird space in it. And so what clean name does is takes away those spaces or other special characters and just makes them into underscores so that you don't have to use those special characters in your data frame names so that you can work with data frames that make logical sense. It also does standardize names and it makes it easier to shorten variable names. So it doesn't automatically shorten variable names. Okay, so this is an example of a piece of code that I use every day in my work. So I work at a set of charter schools. And in my work, that means that I every day have to deal with, wrong way, have to deal with student enrollment files. So I might look at school X and I want to see what their enrollment looks like. And our enrollment files can be in Excel are almost always a mess. So the way that I initially clean it up, and again, this is like the top of every single one of my enrollment scripts, are immediately clean its names. So I work with something logical. So you can see that my, can you see my pointer or my mouse? Great, seeing dots. So you can immediately see that what once had spaces or weird capitalization becomes these nice entry date underscore, exit date underscores that makes it much, much easier to work with my Excel data. Janitor also has these lovely helpful column functions like remove empty, which automatically removes all columns or rows that are just NAs all the way through, and this Excel numeric to date, which automatically converts the weird Excel numbers into actual dates. Though it doesn't work the other way around. When Excel accidentally changes everything into a date, it does not undo that yet. I keep bugging Sam to see if there's a way to figure that out. So that's clean names. It's pretty simple. It cleans names. You will have a chance to poke at it in the data. But the sort of bigger function that we're gonna focus on is, question. So remove empty for rows would be the same as drop NA in tidyverse. Kind of. So drop NA removes any rows that have any NAs in them, whereas remove empty removes rows that have all NAs in them. So drop NA will, if you have like a value in the first column but no values in the rest of the data, will remove that row, but remove empty will not, because remove empty only removes it if it's completely empty. But they are similar. Okay, so get dupes, our second function of the day. So the way get dupes works is it provides you duplicates in your data for some grouping level. So it's got two inputs. Well, first of all, can I see nods for, have people seen pipe notation before? Because I'm assuming that people know pipe notation. Great. If pipe notation is confusing, type in the chat and someone can help you. But we're going to use it through the rest of the presentation. So if you're confused now, ask. So the first argument for get dupes is the data frame that you are working with. And then the next arguments are the name of the columns that you want to check for duplicates. So this has the same syntax as group by, for example, where you list out all the columns that you want to be grouping for without quotes. So you're just listing the name of the column like in any of the dplyr functions. So for an example, and this is code that you should have available for you to run in your Janitor notebook from your students' data. Because I did an RNorm to make the students' data, your data is not going to look exactly the same as mine. But it should be similar enough that you can understand what's going on. So I have set up this fake enrollment data of students, and I am seeing what duplicates I have by student ID. So student ID here is my unique identifier across my enrollment file, across my students file. And I want to see what is causing duplicates. So we see in this example, what is causing duplicates is that this one student, so same ID, is enrolled in two different grades. So they are both enrolled in 5th grade and in 6th grade, which annoyingly happens all the time. With enrollment data, we have a student enrolled in 2 different schools or enrolled in 2 different grades, and then we need to go call the school and figure out what grade they are supposed to be in so that we can actually look at clean data. All right, so does anyone have any questions or does anyone have any problems running this code on their computer? Not seeing any totally confused faces. Great. All right, so now that you've seen an example of what get dupes does, we're going to go back to the first thing I said, which is that the janitor functions are largely just dplyr functions, but created for you. So if this is an example of what get dupes is doing, what dplyr functions make up the function of get dupes? And again, if you can put them in the chat. Seeing some good answers so far, but only seeing them from 2 people. I'll wait for a couple more people to get in. I'll go back so you can see what the output looks like. So we see there's definitely some grouping, there's definitely some filtering, there's probably some arranging. I think we're missing just one. There we go. Mutate. All right, so thank you for all of your answers. So in order, it's basically a group by mutate filter select. You can imagine the mutate and the filter can be switched around as you so choose. But yes, there is definitely a mutate for the result because it counts how many duplicates you're seeing. So if we go back to, you'll see that there wasn't this dupe count in my original data frame that gets added on as part of get dupe so that we know how many duplicates are showing up. It's filtering to only the duplicates we want. And it is selecting the column that we are grouping by first and then adding the dupe count column and then putting everything else. So it's these four functions combined make up just the one get dupes function. Does anyone have any questions on that? Nope. Great. Okay. So now we've found the duplicates, which is great and very exciting. But we've only worked through like 10% of the amount of work to clean the actual data here. We found the duplicates, but we need to correct the duplicates or clean the duplicates out of the data. So there are three sort of basic ways to start cleaning your duplicates. So one is that once you have and have looked at your duplicates, you see, oh, in this case, there was only one duplicate. If it was this particular student ID, and I know which grade is the correct grade, so I'm just gonna fill it in with a mutate statement and use distinct, which will take the two rows that are now exactly the same and collapse them into one row. And voila, I have gotten rid of my duplicates. And this is super handy when you have like 2 or 3 duplicates and you know exactly how to fix them. You can just fix them in one mutate statement with either an if else or case when statement. Something where you can call out exactly the identifier that you want and the fix that you want, and then just distinct to make the sort of row copies be one row so that you're removing the duplicate row. But if you have like 300 duplicates, that's just not a feasible way of solving the problem. So in our second way of solving the problem, we can make a business rule decision on the column that is wrong to pick which one we want, for example. So in this example, I'm saying, okay, well, I know that of the like 20 students that I see in this data, the incorrect data is always their larger grade. So I want to just keep their smaller grade, and that is a business rule that I am applying to my data set to solve my duplicates. So this is really a great way to look at things in my data sets, which again is all education data. Say when I'm looking at exam scores or homework scores, we might either want to take the benefit of the doubt for the student and be like, okay, we don't actually care about diving into the deep to figure out exactly what grade you scored on this homework. So we're just going to give you the higher grade because we trust you. Or we might say, well, we're actually being too lenient in the rest of this data and we want to take your minimum grade because we want to make sure that we're counting you correctly. And we don't want to put you in the higher group if you don't belong in the higher group, for example. So we have a question that is, how do you record the rule that you're using for this? So that's a great question, Evelyn. What I'll do is put it in a comment where I'm writing the code and I use like a capital BR to say business rule. And then I write out whatever rule I'm choosing and why I'm choosing it. And I just put that either if I'm writing in a notebook, I'll put it in actual text form so that when I run the report, it shows up in text form, or if I'm putting it in like an R script, then I'll just leave it as a comment. But I always use capital B, capital R, colon, so that I know that I can basically search for business rules if I'm ever confused about what business rules I'm using. And that way I know what the difference is between like a business rule that I've put in place and a like example of code or like a more code specific comment, for example. And yes, to put comments in your code, you just use the hashtag before your text. So this is not the only two ways of solving your duplicates. We also have option 3, which is when you have too many students or too many duplicates to work with one by one in an if-else or case one statement, but you don't have a universal business rule that you can apply across all of your duplicates. So in that way, you might want to just write the get dupes output to a CSV file, pass your CSV file over to someone who can help you pick out which is the correct row for every single time you have a duplicate. And then in my case, what I usually do is create a column that's like, delete this row. So then when I bring back that data in, I know which rows I need to remove from this new edited data set, and I can use the function anti-join because these are the rows that I want to remove. So I anti-join these rows on my original data set, and that also just removes them, all the ones that I want, cleaning my data set. So version 1, using if else, great when you only have less than 5 duplicates and you know exactly which ones you want. Version 2, great when you have a universal business rule that you can apply to all of your duplicates. And version 3, annoying because it's super manual, but when the other 2 options don't work, this is the best way of doing it. Does your anti-join go to the new data frame, or are they just deleted? So anti-join rows are deleted out of your initial data, but only if you assign that variable, assign that to a new variable. So they're not completely removed out of students, they're only removed out of students if I were to say students arrow anti-join. Did that answer your question? Great, thank you. I appreciate everyone putting thanks in the chat after I've answered your questions, that I know that if I've answered your question correctly, or if you're still confused or not. So please continue to do that. All right, so this brings us to our practice set. So you're gonna do some work on your own now. So I've provided you with a practice SAT exam set. So again, I work in education, so I work with this exam data all the time. So I've written the function, the read CSV function in your janitor notebook. It's the like last chunk in that notebook. So look at the data set. What do you see in the data set? What kind of data do you think that you're looking at based on the fact that it's named the practice SAT exam set? What might the data be unique by? Specifically, what is the student identifier in the data? What columns do you want to include in your dupes check, and what business rule should you go about using to solve your duplicates, and which of the versions are you going to use to go about correcting your duplicates? So I'm going to give you a couple minutes to do this on your own. And I will be looking at the chat to see if you have any questions. You could also feel free to unmute yourself if you, and just ask if you have a question that you think everyone would like to hear. And for anyone who joined late, it's super helpful for me if you turn your camera on so I can see your lovely faces to know whether or not you are confused, so that I know whether or not I should slow down. Is the data the 10 observations of the 5 variables? There should be, no, this is the exam data set, not the student's data. Molly. I see nodding, so I hope that answered your question. So I can flip over So what I want you to be working on is this Prac SAT data set at the bottom where it says your turn. So it is 3,247 rows, apparently. And this is fake data.
Erin, I love the idea of adding a column and using an anti-join on that, because I normally export dukes and I get feedback and then I write that into my code which ones to remove, and it's much more complicated than just doing the anti-join. So that's a great idea.
Yes, anti-join your dupes away.
Yes, that's a great idea.
You already have the written output of which ones are
yeah, that's great.
Unnecessary.
Hey, Erin, I have a question about the names.
Yep.
The clean names. When you said special characters, I assume like punctuation and spaces. Does it do anything to like accented nouns or anything like that? Like if you're using UTF-8?
Yes, I believe it does, but I don't remember its exact rules.
Okay, great. No, that's just something I should look into since I work with a lot of data that has special characters like that.
Yeah, and it only changes if like the column names itself, so it's not going to affect the actual data.
Thank you.
Yes, JH confirms that the accented characters are translated. And we have lots of love for anti-join happening in the chat, which is great. Great. I'm going to give everyone one more minute to finish up. Feel free to type in the chat if you don't think 1 minute is enough. And then if I can get a volunteer to speak out loud to answer the questions, that would be great. I will call on someone if I don't get a volunteer. All right, Erin is a minute. Do we have any volunteers to walk through their answers to a couple of these questions or their code? Anyone? All right, I will pick somebody. How about Irene?
Sorry, I forgot to unmute myself. I think the database, we have 2 observations for each student. And so we have to check, it's unique if we look at student number plus subject.
Yes, so that is the important part of this data. The really great call out is that this, unlike our previous enrollment data, when we're looking at exam data, often the student identifier itself is not enough to have the data be unique. So this data is unique by student exam, and the exam consists of the subject, and in this case, it also consists of the cycle, the grade, and the test version, but all of those things are already unique about the student. So you don't need to include those in your group by if you don't want to. But they do all make up the exam itself. So all of those things, or at least student number and subject, need to be included in your DUPS check. Thank you. I'm going to call on someone else so that we can figure out what business rule you used. So how about Briha? Did I get your name correct?
Yeah, hi. Yeah.
What business rule did you choose?
All right. So this data is it's an SAT exam score data that reports the SAT scores of the students. The student ID, which is actually the student number, is sorry, my toddler's in the background. So that is like a unique ID for the student. But so what I don't know, we call this like it's not correlated data, but how every student, what's the score of a certain student in math and English. That's what's reported, right? And
that is what's reported.
Yeah, and what test version they took. So I'm confused about grade. Is that the grade level, or is that the grade that was reported?
That is the student's enrollment grade. So that is whether they're in 10th grade or 9th grade. That's a great question.
Okay, perfect. And then the academic year and the school that they went to.
Mm-hmm. So were you able to correct for some of the duplicates after you found them?
Yes, and actually I could not because there's some problem with my code.
Fascinating.
When I go into the RMD, janitor RMD file,
mm-hmm.
Actually I've been trying to troubleshoot that. It's somehow like, you know, it throws an error when I do the mutate grade FL student. And so I don't know how to figure that out.
That is super weird. But if you can post an issue to the GitHub link, I think that's the best way for us to solve it so we can see exactly what code and error you're looking at.
Okay.
But thank you very much. In the meantime,
right.
I am going to call on someone else. Lisa.
Lisa. Hi.
Duplicates.
I was hoping you wouldn't call on me. I actually am not quite there yet. I have just found the duplicates. I just installed RStudio, reinstalled it today, and my file path was off. So I finally got that fixed. And so I've found the duplicates I'm seeing though are the student number. Like there's multiple records for each student number because they have a maths and an ELA score. Mm-hmm. But that seems like a reasonable, like,
yeah,
what I'm assuming is like we need to add the ELA and
so
the score to the same row is the other.
Yes, so I'm gonna provide an example of what this should look like. Normally I call on people to share their screen and then that's how we do this. But that's super annoying over Zoom. So I'm just gonna type it out for you. So you'll notice that finding the duplicates looks something like this. And feel free to type in the chat if you are confused. But we know that student number is the identifier for the student, and we know that we need to look at each student's exam. So our sort of groups are student number and subject. And then if we scroll over, we'll see that the thing that is duplicated is this % correct, which is the like score that they received on the exam. And we see that we have 14 rows of duplicates, which means that we have 7 duplicate exams is the way that I like to think about it, because our dupe count is 2 all the way down. So these are our duplicates. So Lisa, since you're still unmuted, I'm gonna continue to call on you.
Okay.
So now that we've found the duplicates, what do you think is the best way of fixing the duplicates?
I was going to say mutate, but that's the only part you've given me. I'm assuming we want to add the.
I can go back to our slide of correctness.
Okay.
Evelyn has given you a hint in the chat.
Oh, I see. I'm choosing between the two. Okay. So then I guess if you did like the version 2, then you would select the maximum score for the exam. I can't, the percent correct.
That is exactly what I would do. So in this case, I would regroup by student number and subject, because GetDupes ungroups its grouping. And one way of doing that is just taking the correct and doing a max on percent correct. And then that. And now you'll see that we've created the same percent correct for all of our duplicates. So if we distinct it, that will remove the duplicates. So now with my fixed data, if I re-add my GetDupes in here, you should see that we have 0, assuming that I spell student number correctly. Oh, yep, that makes sense. Always ungroup your groups. There we go, 0. Hooray, fixed. So thank you, Evelyn. Thank you, Lisa. Thank you, Irene. And thank you, Bria. Are those all the people I called on? Thank you to everyone I called on. I will call on new people going forward. So yes, in this case, what I would, the business rule I would pick is taking the maximum percent correct, because this is practice SAT data or SAT data, and we want to give the students the benefit of the doubt that they scored as high as they possibly could. All right, so that is Janitor. Hooray, you've learned a new package. Good job. Again, feel free to put any questions you have in the chat, though I have lost the chat window. Let's see if I can bring it back. There it is. Great. All right, so we are going to move on to working with Tidyr. So Tidyr is part of the Tidyverse collection of packages. So it's probably one you've seen and used before, but I am going to go into a little bit more detail on exactly how the two main functions, pivot wider and pivot longer, work, and how they work to clean your data, and why you should use them as much as possible. Great. So we are going to start with this quick fake data of countries. Oh, before we jump into Tidyr, you have there's a notebook called Tidyr, just like there was a notebook called Janitor. So we are now switching notebooks. So if you haven't already, open your new notebook so that you can follow along in the Tidyr code instead of getting lost in the Janitor code. And that way you'll have the sort of fake data that we're gonna use. Quick quiz. What are the variables in this data set? Someone can write them in the chat. Did I lose everyone to opening up the notebooks? So we've got country and year. Country, year, cases, and population. Yes, thank you. So basically, we are looking at tidy data at the moment. So every variable is in its own column. Nothing is confusing. We can work with this by grouping by countries or by grouping by years, looking at counts of cases and populations. We don't have to get too lost with any of our group bys or mutates or normal dplyr functions when we would look at this data, because our variables are where they're supposed to be. Now, how about in this data? Just the same information as we were looking at before, just in a slightly different format. So what do we think? Do we have the same variables, different variables? You've lost a column. Does that matter? Right? Type is now case and population combined. Type is now case and population combined. But that didn't change our actual variables, or the things that we're measuring about the data. So we've just made our nice tidy data long but untidy. So this might be an example where it's easier to work with a column called type and a column called count if you want to make some ggplots, or if you want to do some per loops or for loops around type instead of having them as separate columns. But it's not technically tidy data because our variables are all confuzzled into this one column called count. So the way that we get back and forth between these types of structures is pivoting the data either long or wide. So in this case, going from data A to data B, we've made the data long. So we've removed cases and population as two different columns and combined them into two longer columns. And then untidied the data as we were doing that. So definition of tidy data. Each variable is in its own column, and each case is in its own row, and each value is in its own cell. Do we have any questions? Not seeing questions yet. The reason we want to keep things as tidy data is because the dplyr functions were sort of built to manipulate data in this particular structure and format. So it's easiest to go from, for example, number of cases to the rate of cases by simply dividing the cases by population when you have them in two separate columns, which that would be much harder to do in this version of the data. All right, now we almost never in my life have data that's provided in this each variable is in its own column, each case is in its own row, and each value is in its own cell formats. So we are often sort of switching between different structures and different formats. And the way to do that are with two functions called pivot longer and pivot wider. So we're gonna walk through examples of each, and then an example maybe that uses both if we have time for it. So we're gonna start with pivot longer. So we're gonna use this example wide data that's at the top of your notebook. That's called cases, and it will look at this country data. And for anyone who's been through like an RStudio official training before, yes, these slides are exactly the same as the RStudio official trainings because they are available for free online, and I stole them and edited them for my needs, which is within the way that they want you to use the data. So this might look very familiar to a lot of you. And that is okay. All right, so we're going to use this country data. So normally I do this with a sheet of paper, but if you don't have a sheet of paper in front of you, feel free to open like a blank Excel doc or a blank Google Sheet doc, and we are going to write out what this wide country with data would look like as tidy data. So into the 3 columns of country, year, and N. And I'll give you a few minutes to do that.
Erin, I think you have a question about what a tibble is.
What is a tribble? That is a great question, Evelyn. It is, so a tribble is a small creature from Star Trek, but it is also a way of writing out a data frame in this sort of column and then value structure so that you can easily see what it looks like inside of R. So you may have seen the like data frame version of doing it where you do data.frame and then x equals 1 through 10, comma, y equals 20 through 30 as a way to create a data frame. So this is another way to create a data frame inside of RStudio, but you write it out explicitly instead of writing it out sort of column by column. Did that answer your question? Does the, yes. The squiggly line marks the name of the columns, and then you fill in the rows underneath with commas. Exactly. Right. For anyone wondering what the silence is for, we are creating our nice long and tidy data out of this messy data frame. This is also where I get to call on someone to shout out what the first couple entries of the long data look like. So while you're doing that, I will choose someone at random. All right, I'm going to choose Hannah Wiltz. And feel free to tell me, no, you're doing something else. Hannah, can you give us the first entry?
So are you meaning like the country that you're talking about there?
Yeah, so what would the first row of our new data look like? And I don't know why none of my titles are showing up anymore. That's really weird. But if it were, what did I say? Country year N. What is the first country year N?
So that would be the 2011 one?
Yep.
Is that what you mean?
Yeah, so which country do you want to pick with 2011? Doesn't matter.
Oh, so France.
Great, so France 2011, and the value is?
7,000.
7,000, correct. Thank you, that was all I was looking for.
Okay, sorry.
Nope, you got it. So all of my column names are showing up as blank, which is very strange. But I'm just gonna walk through the rest of these. So we start with France 2011. Thank you, Hannah. And then going down, we go to Germany 2011, US 2011, and then we flip over to 2012. And we do all 3 countries, and then we flip over to 2013, and we do all 3 countries. And then voila, we have pivoted our wide initial data over to long data. And in this case, we now have our 3 variables as actual variables. And the function that does this is pivot longer. So if you learned tidyverse functions a year ago, 2 years ago, I don't remember when the name change happened, but you might remember spread and gather. So spread and gather have been renamed to make more sense of what they're doing. So pivot longer was what was previously called gather, and pivot wider is what was previously called spread. So for those of you that learned gather, pivot longer is the same function, just renamed with a couple different arguments. So the way that this works is that it takes the former column names and creates a column out of them, and then creates the former values and creates a column out of them. And the assigning of that is names to and values from, because the names are coming, the names are moving to a particular column and the values are moving. And so in R, that actually looks like this. So we're in our cases data, we would use pivot longer, and then we are specifically calling out columns 2 through 4, so columns 2 through 4, with the names to and values to, and naming those year and end. I got it very helpful. Thank you. Glad to see this is helping. If I'm confusing anyone, again, either show your confusion on your camera or type a question in the chat so that I know. I'm not seeing too many confusing faces. Great. So there are a couple ways of supplying the selected columns that you are pivoting. So what I've shown here is an example using the number location, so just using columns 2 through 4. But you can also select by the names of the column. So this again uses the funky quoting because we haven't cleaned names of these columns. So we need to use the funky quoting. And again, it just says, can select the columns from 2011 to 2013. The colon says select everything in between those. Or we could say select minus country, which is everything except country. And I see a question that, so pivot longer was gather. Yes, the arguments are slightly different and the functionality is about the same. But the arguments are slightly different and it can do a little bit more complex things than gather could. Just the same with pivot wider. Pivot wider has the most, I think, unique changes to it in terms of its complexity. But yes, you can think of them as the same. So here's just a summary of those 3 examples of selecting. So again, my names to and values to, which are the arguments to pivot longer, are staying the same because I'm renaming my new columns the same way. I'm just selecting the columns that I'm pivoting in slightly different manners. Right, so quiz. So here are some basically some code. So some of these work, some of these don't work in terms of creating tidy data and using pivot longer correctly. So which ones are tidy data after running the code? And if you didn't install baby names, that's fine. We won't really be using it too much. But it looks like the name of the child, the gender of the child, the year, and the count of babies who were born with that name of that gender in that year. So you have an idea of the structure of that data. Ah, feel better, Maggie. There will be a recording. And to anyone else who needs to be doing other things or wants to follow along later, there will be a recording. Just let me know if I accidentally choose you to talk that you are, that you plan to watch it later, and that's totally fine. So I'm seeing a couple answers in the chat. I'll wait for a couple more answers in the chat. Feel free to run the code. I think I provided all the examples in the notebook, so you shouldn't have to type them all up. You should have them available to run so that you can look at the output and see what works and what doesn't work. I'm seeing a lot of 3s, a 2, a 4. There is more than one answer. Give everyone one more second. And again, if anyone is really struggling just to run the code, please put that in the chat as well so that I know. All right, so I'm seeing a bunch of 3s and 4s and some 2s. So I'm gonna go ahead and show you the answer, which is 3 and 4 are both correct. And we'll both give you tidy data. And that's fine, JH. I don't have to run it directly. So great work to everyone. Having an issue with baby names when I try to run it, I get attempt to use 0. Maybe someone can help Molly with that problem. But Molly, we're not going to be really using baby names too much. It was really just useful for you to look at the structure of this data. So I don't think you will need it going forward too much. So that is okay. Everyone pretty much got that 3 works, which is great because 3 was our example of how to use pivot longer exactly. The reason 2 does not work is because of the minus sign. So pivot longer, the first element again is the columns that you are selecting. So when you are selecting just country, it doesn't do anything to actually pivot the columns. But when you minus select country, it selects all the other columns, i.e. are like years, and brings those into names here. So that is why 2 is incorrect and 3 is correct. And then baby names is just a ready-made tidy data. So you don't have to do anything to it to make it into tidy data. Molly, if you, Mary says if you have the 0 length variable name, it's usually because you've accidentally highlighted the backticks that are part of the notebook code. And so if you make sure that you're only highlighting the baby names part of it, that should solve it. We hope. Great. So that was pivot wider. That was pivot longer. Now we're going to move on to pivot wider. So again, if you have any questions on pivot longer, put them in the chat before I move on. But I'm going to move on for now. So we're now done with cases for a little while, and we're going to move on to a data set called pollution, which again should be in our notebook directly under cases. And it's going to be our toy data for this section. And we're going to start by doing the same thing, which is defining our variables in the pollution data. So think about that and then put it in the chat. And that says city and particle size and amount for anyone who can't see the white text. And I swear it was black 5 minutes ago when I tried this out. PowerPoint usually works okay as a live demo. You can usually trust it, but I guess not always. All right, so Evelyn says city, small particle count and large particle count should be our variables, which is correct. So we see that we have city as something that makes logical sense, and then we have this confusion between large and small, which doesn't really make much sense. So we want to separate out particle size into one column that says large and one column that says small, and then amount underneath. So we're going to do the same exercise that we did previously. So either in your Google Sheets or your Excel, make sure you have a blank starting place or a piece of paper. If you have a piece of paper in front of you, we're going to write out what our three columns of city, large, and small would look like from this toy data. I'm going to just go ahead and make this black. Yeah. Again, this is our toy data, and we are creating, just gonna go in and bring my column names back, at least for this first slide. All right, we got column names back. I'm going to give you a minute to detail out what this would look like before we introduce the pivot wider, and then I'm going to call on someone to read me out the first row. That person is going to be Janine. I haven't called on you yet.
I'm not caught up with everyone, sorry.
That is okay. Are you comfortable reading out the first row anyway, or would you like me to call on somebody else?
Okay, New York and 23 and 14.
Yes, exactly. See, that wasn't so hard.
No.
Thank you very much.
Sure.
So we have New York 23 and 14. And so then just hopping down the line, for London, we've got 22 and 16. And for Beijing, we've got 121 and 56. So we've made our long data wide. And now we have variables that are in their own column, and cases that are in their own row, and values that are in their own spot. And the way that you do this in our code is with the pivot wider function. So again, this used to be spread and is now pivot wider, but they act very similarly, except that pivot wider does a lot more. So you might remember from using spread that you couldn't move more than one column at a time. So actually pivot wider has some complexity that allows you to spread out more than one column at a time, which is great, but that is not the example we are showing. We are showing just one column at a time for now. So the way that you use pivot wider is that you have a name that you're getting your names from. In this case, that column is called size, and you're getting your values from a column called amount, and then you put those into the pivot wider function. So the arguments are names from and values from, which looks exactly the same as pivot longer, except that that used names to and values to. And so now, since we're going the other direction, it's names from and values from, but they're otherwise named similarly. And our names of those were size and amount so that we get the data that we are looking for. So then it goes from being long to going wide.
Can you go back real quick?
Go back. To here or one more?
No, that's good. Okay, I'm good.
Great. I lost the chat again, so.
Yeah, Erin, you have a question. Which way is the data considered tidy?
That is a great question. So going back to our, let's see if I can go back to that slide. Going back to our definition of tidy, tidy data is when each variable is in its own column, each case is in its own row, and each value is in its own location. So when we look at the long data in this example, we're seeing that we have two variables, so large amounts and small amounts that are in one column. So that is not tidy data. Because we want to be looking at large separate from looking at small. So in this case, the wide version of the data is the correct tidy version of the data. But there are certainly situations where that may not be the case. So it can be very specific to the type of data. I know that's a confusing way of answering that question. What I like to think of it is, can I do the thing that I need to do using dplyr commands? Like, does mutate work on the data the way that I want mutate to work on the data? What was the third part of the definition of tidy? So first part is variables, second part is cases, third part is values. So the values should be in their proper location. So you don't have like sometimes you'll get Excel sheets where the value might be all within one cell, but separated by a return. That would not be considered tidy because your values would be in one Excel and not in two Excel, for example. In education data, you see everything. I don't know why people put their data in returns of the same cell, but they do. Great, okay, so now that we've seen an example, so a couple of tips and tricks for using Pivot Wider. I find that most tidyverse functions are made to work with sort of the longer version of tidy data. So if you are looking to output the sort of wider version of data, then it's sometimes better to wait till near the end of your code to shift over to wide data so that you can do as many of the dplyr commands as you need to on the data that is tidy and makes logical sense for you. So at least in education, I'm often asked for example, we have state exam data when at least states do state exams. So with COVID-19, basically no states had state exam data last year. But the following year, we have lots of state exam data. And on state exams or on AP exams, actually, which you are probably more familiar with, you can score a 1 to a 5. So you're not scoring like from 0 to 100, you're scoring a 1, a 2, a 3, a 4, or a 5. And often what we want to do is look at the number of students per school who scored at each of those levels. And we want each of those levels to be their own column. And so it doesn't make any sense for me to pivot wide the data out initially because I need to count all my levels first. But then I want to pivot wide at the end so that each score is actually in its own column. Do functions tell you if you want long or wide data, or do you have to figure that out? So the pivot functions tell you the direction that you're going. So pivot longer makes long data, pivot wide makes wider data, which is the main reason from moving from gather and spread to pivot long and pivot wide. which I love. But the regular dplyr functions themselves are not going to tell you exactly what you need. You're just, as you work with them more, you'll get a handle on the best structure for what you're trying to do. So for example, if you were trying to add, so going back to our toy data, if you were trying to add the amount of large plus small so that you got the amount of things happening in Beijing, you would want those to be separate columns so that you could easily do mutate large plus small. Is long data still considered tidy? Sometimes. So if we go back to our example of using, of making wide data long from cases, so I'm just gonna go back a lot of slides. So this data over here is definitely more tidy than our initial year's data, because we do want to be working with year as a column. So yes, sometimes the long version of the data is the tidy version of the data. And sometimes the wide version of the data is the tidy version of the data. There's usually like an in-between. You can always go longer and you can always go wider. So the magic is finding that middle place where it does make sense. And yes, that can take practice and really working with the data that you have available to you, and only you will know kind of when it's at its point that it needs to be in. I hope that helped, JH. I'm not seeing nodding. That's fine. So yes, great, thank you. So move between them only when you need to move between them. That's basically our first tip. Our second tip is that you may have weird and erroneous duplicates that show up if you keep extra columns along when you're working with Pivot Wider. So we'll actually see an example of that in a second. But the sort of tip here is that it's best to select only the columns you really need before using a Pivot Wider, just to make sure that you're not going to have a problem with NAs and duplicates. And my last tip used to be that you can't Pivot Wider more than one column, except that you can now, which is very exciting. So I'm not going to go over how to do that in this particular workshop because I don't have the time. But the Pivot Wider help file has more information on how to do this if that's something that you struggled with using Spread, or if that's something that you want to learn more about. All right, so we are going to practice with an example of where Pivot Wider might create these weird duplicates. So you should have this set up in your tidyr notebook, where we've got schools, teachers, subjects, and then the average per teacher. And what we want to do is make the data wide by subject. So we want to be looking at school, teacher, and then ELA math, and then have the average per teacher that way. So I'm going to give you a second to write the code to do that. And then hopefully you'll see where your problems are. And I helpfully titled this data set Wide Fail. And if anyone is struggling to find the toy data that we're working with, or struggling to pivot it, please let me know in the chat. This is how you might do that. So you would Pivot Wider, and your names from would be subject because we want to create the ELA and math subject columns, and our values from our average, which was our percent column. So now that we've done that, what appears to be the problem here? Mary, since you answered in the chat, can I call on you to answer to the full group?
Yeah, that's fine. We seem to have gotten a couple NAs in our data from pivoting wider with this data set.
Yes, exactly. So not only have we created some NAs, we've also created an annoying duplicate. So teacher A is now in there twice, each with one ELA and one math and an NA for their respective other column. Mary, can I call on you again to see why? What is the reason that happened?
Oh, the duplicate?
Yeah.
Probably because you have two things that because you have two different variables that have that same pattern of names from. So subject, you have both the math and the ELA, and then you have the teacher AB. And so I think that's messing up the data and causing the duplicate. Is that correct?
That's part of the way there, yeah. So what really is so yes, the problem is that we do have sort of a row for A math, a row for B math, a row for A ELA, a row for B ELA, but the reason we only got one row for teacher B with both of their ELA math and math scores in the same row, and that didn't occur for teacher A, is that teacher A teaches at two different schools. So they teach ELA at UCC, and they teach math at UPC, which means that now teacher A is duplicated across the two different schools that teacher A teaches in for each of their subjects, which is often not the way that we want to look at our teachers. We want to look at the teachers uniquely and not necessarily this duplicated by school issue. So you see that we have these two rows for A and they're at two different schools, and that's annoying. So the way that we would fix that is just by deselecting school before we pivot wide, and then you will see that teacher A gets one row. I'll give you a second to deselect your school. And then you'll notice that hopefully you only get two rows when you then pivot wide. And if you can nod when you've done that, that would be helpful. Or put a thumbs up on your name. I'm seeing nodding. Great. Great. I'm going to assume that makes sense to everyone then. Again, put the chat if you have questions, if that doesn't make any sense to you. Smiley face. Excellent. Thank you. So this is just an example of this second point here, that you need to make sure that you select only the columns you really need. Otherwise, you may create these rows of duplicates that may or may not be problems. So if I really, really needed to know what school a teacher was at for their particular subject, then this is actually the way that I would want this data, and it would not contain any problems. But I often don't want the data in this way. I want to know information about the teacher specifically, and I don't want them to have these weird duplicated patterns. Great, so we're gonna move on to this final check question, which is where we're gonna use this baby names data. So for anyone who is having trouble loading the baby names data, it is perfectly fine to not do this example. But if you do have the baby names data, just showed you part of the answer. We're going to reshape the layout of the data in order to calculate the ratio of male to female children by year. And I'm going to give you 2 minutes to get the first part of that. And then I will show you the answer to the first part and then give you another 2 minutes for the second part. Oh, bye, Evelyn. It was nice to have you. Thank you for typing in the chat. For anyone who's never seen the baby names data before, if you're having any questions or problems with it, again, please post in the chat or private message me so that we can help you. This part of my workshop usually comes after 2 hours of only working with the baby names data. So I forgot to include that in the beginning of the example for this particular workshop. Also, it's just a really fun data set, and you should go and find yourself and see how many babies were born with your name and the year that you were born. All right, so that is 1 minute up. So I'm going to show you the dplyr part of this code. So you need dplyr and you need pivot_wider. So for anyone who is struggling on the dplyr part of the code, here's the first half, and then I will let you pivot_wider it to get to the second half. And if anyone hasn't been introduced to dplyr yet, feel free to also ask questions about that in the chat. This workshop sort of assumes that you have that basis to start with, but I'm sure that not everyone does. So I'm happy to answer questions about what the heck Summarize is doing here. Anyone has any questions about that? Now stop screen sharing just for a moment so that I can type up the actual answer to this problem, so that I make sure that you can see what the correct result should be. Actually had it in the deck. Yay for preparing. If you are done already, feel free to put a thumbs up sign on your face or to type in the chat, or if you need an extra minute or two, also type in the chat. If I don't hear anything, I'm just going to give you an extra minute. seeing thinking faces. So I will give everyone more time. There was a private question about whether or not this is being recorded. So just to remind everyone, yes, it is being recorded. And I'm sure that the lovely organizers will figure out a way to distribute the recording. Ah, Crystal says there will be a YouTube link. That's exciting. At Our Ladies New York City, which is where I co-organize, we have like a ton of recorded videos that we just haven't gotten around to editing to put up on YouTube. But they will also exist someday. All right, if you are ready, thumbs up sign. If you need an extra minute, chat. Seeing some thumbs up signs and a lot of people with their video on, which is fine. All right, I'm gonna go ahead and show the answer. So it looks like most people are ready. But first, there's a question. Could the organizers also distribute a copy of the chat, please? I will leave that to Crystal or Mary to answer. Crystal says that she'll see what she can do. All right, so the answer. Ta-da! So from baby names, we saw the group by and summarize. So group by year and sex and summarize by N counts or summarizes all of the N sizes inside of a particular year for a particular sex. And then once we have that summarized data set, we want to pivot wider with the names from sex so that we get the 2 columns of male and female and our values from N. So we have our values under the male and female columns. I like to then clean names so that I can work with lowercase values and then mutate to create the ratio. In this case, it's just F divided by N. Does anyone have any questions? Did that make sense? Ah, you can output your own copy of the chat, so says Gary. That's awesome. Thank you, Gary. All right, so now in this example, you've used a reminder of how some dplyr function works. Your pivot wider. I threw in clean names to bring us back to the beginning of the workshop today, and then a mutate, and that is all I have. So again, all of this information and slides and notebooks and data is available at this particular GitHub link. And I can be found on Twitter or GitHub or a blog that I never write anything in. But I have so many drafts sitting on my computer, so there might be something coming up soon. And I am happy to stick around for the next 20 minutes and answer any questions or just chat. Yeah, that's it.
Thank you, Erin. This is great. That was awesome.